Last time, we built a live countdown timer using Python and Pygame. Now, in part 2, we're bringing the game to life, starting with the car. We're building the exact timing game that blew up with 190,000 views. Ready to code? Let's dive in. First, what we're going to do is get our car image. I got mine from icons8.com. Make sure your image is saved in the assets folder and named exactly car.png, or Python will give you a file not found error. What we can do now is in our main.py, we can load this image. Car equals pygame.image.load assets car.png. We're going to make this image a button. The reason we are doing this is because when the user clicks the car, we need to stop the timer. So we need to make our car image clickable like a button. So let's do that. Create a file called button.py, and that is going in my racing game folder. We're going to import Pygame, as that is something we're going to use throughout this file. Let's create our button class. The button class is like a blueprint or a template for creating individual button objects in our game. Let's define our special setup method, init. The init method is automatically called every time you create a new button object. It helps us initialize or set up the button with its starting properties. Let's define it. It takes self as its first parameter. Self is a special keyword in Python that refers to the specific button objects we're currently working with. So when you see self dot before a variable or method, it means this particular button's ... or like perform this action for this button. The base image is the picture or image that our button will display. X pause, Y pause. These are the coordinates on our screen where the center of the button will be placed. Base size, the size of our button's image. Button text. This is any optional text we want to draw on top of the button, like when we have our levels easy, medium, and hard. The equals quotation makes it optional. Self.click effect timer equals 0. This is a counter that helps to create a little bounce effect when the button is clicked. Self.text color equals white. This sets the default text color and it applies to our easy, medium, hard labels. Then the init method automatically calls self.adjust size and position. This adjust size and position method will be responsible for setting up the button's initial image size and its hitbox, which is the invisible rectangular area that Pygame uses to detect if your mouse cursor is over the button. Let's set up all the methods we'll have in this file. The leading underscore is a common Python convention to suggest that this method is primarily an internal helper, not typically called directly from outside the class. We'll just write pass as a placeholder for now. Define update and we'll pass in self, screen, and fonts. This handles effects and draws the button. We'll also write pass as a placeholder for now. Define check click. We'll pass in self, position, clicked countdown value, and random number. This checks for a click, triggers effect, and returns the result. Pass. Define update text color on hover. We'll pass in self, position, hover color, and the button text color. This updates text color on hover. This is specific to level buttons. So now let's work on adjust size and position. This method is responsible for updating the button's image and its rectangular area, rect, on the screen. First, let's work on the scale factor. When the car is clicked, the car will become temporarily bigger. So scale factor equals 1.2 if self.click effect timer is greater than 0. Else, it's 1. If clicked effect timer is greater than 0, meaning the button was just clicked, the scale factor becomes 1.2, which means the button will temporarily become 20% larger. Otherwise, it stays at 1, which is the normal size. Next, we get the current size of the button. Current size equals int, and we'll pass in self.base size multiplied by scale factor. The base size is multiplied by the scale factor to get the current size the button is right now. We use int to convert this number to an int if it isn't already. Now that we have the current size, we can use pygame.transform.scale to resize the button's image to its current size, the size we want. Self.image equals pygame.transform.scale. We'll pass in self.baseImage, and then we'll also pass in current size, current size. Finally, we can call getRect on that image. Self.rect equals self.image.getRect, and we'll pass in the center, which is equal to self.x position, comma self.y position. A rect is Pygame's way of defining an invisible rectangular area on the screen. We use it to tell Pygame where to draw an image, and it's super important for figuring out if you clicked on something or if two game objects have collided. Next, let's work on update. The update method will be called repeatedly in our game loop to draw the button on the screen and handle its ongoing effects. If the click effect timer is greater than 0, meaning the button is still bouncing, it counts down by 1. If self.clickEffectTimer is greater than 0, then we're going to decrease our self.clickEffectTimer by 1. This ensures the bounce effect is temporary and will eventually hit 0. We call self.adjustSize and position to see if we need to update the button's image. For example, our scale factor could change based on the click effect timer value. Next, we draw the button's image on our game screen using the blit command. Screen.blit will pass in self.image and self.rect. Blit means block image transfer. It essentially takes our button's self.image and copies it onto the screen at the position and size defined by self.rect. Next, we will handle if there's any button text we need to add to our button. If self.button text render equals, we can use font.render passing in the button text. True means smooth the edges of the text, and self.text color, the color of the text. Text render equals font.render. We pass in self.button text, true, self.text color. Next, we can use getRect to help us center the text on the button. TextRect equals textRender.getRect, and we'll pass in center equals self.rect.center. Finally, we can draw the text image onto the screen. Screen.blit, textRender, textRect. Next, let's work on detecting mouse clicks. Let's go to check click. This method is called when the user clicks the mouse. It figures out if the click happened on this button. If self.rect.collidePoint, passing in position. This is the key part. Self.rect is the button's invisible hitbox. Collide point position checks if where the mouse was when it clicked is inside this rect. Self.clickEffectTimer equals 5. If the mouse did click on the button, this starts the click effect timer at 5. This will make the button bounce for the next 5 frames. Next, we determine if the user's click was a win or a lose. Return a list, click countdown value, win if click countdown value equals random number, else lose. This line returns a list. The first item is the current time, which is the value of the counter when they clicked. The second item is a string, win if the current time matches our random number target, otherwise it's lose. Finally, if the mouse didn't click on this button, the method returns none, indicating no action from this button. Return none. Now, finally, let's work on update text color on hover. This changes the text color on hover and is used for our easy, medium, hard buttons. First, we check if the button actually has text. If there's no button text, if not self.button text, we return. Now, let's work on updating the button color. If self.rect.collidePoint position is true, meaning the mouse is currently over the button, then self.text color is set to our hover color. Self.text color equals hover color if self.rect.collidePoint position, if that's true. Else, button text color. Let's run our code to see what we are currently working with. We have our countdown from the previous video. Let's add our car button. We can import button at the top of our file. From button, our button.py, we can import button. From button, import button. We have already loaded our car image. Let's create our car button using our button class. Car button equals button, and we'll pass in car. For our X position, we'll pass in X divided by 2. For our Y position, we'll pass in Y divided by 2. And then for our size, we'll pass in 250. So we pass in the image, X, Y, and also the size. Now in our main game loop, where all the drawing happens, we just need to call our buttons update method. Car button.update, and we'll pass in screen and fonts. Now let's run our code. And our car has appeared on our screen. Let me know if you have any questions in the comments below. In the next video, we'll add our easy, medium, and hard buttons and more game logic. Subscribe to stay updated.